The fate of the universe, Big Freeze, Big Rip, or Big Crunch. Introduction. For as long as human beings have looked up at the night sky, we have asked two of the greatest questions of all time. Where did the universe come from? And how will it all end? We now know that the universe began about 13.8 billion years ago in a brilliant explosion of energy and matter called the Big Bang. Since then, space itself has been stretching and expanding, carrying billions of galaxies away from one another. But expansion cannot go on forever without consequences. Just as every story has a beginning, our cosmos must also face an ending. Scientists today are exploring the ultimate fate of the universe, and three dramatic possibilities dominate the discussion. The Big Freeze, a slow fading into eternal cold and darkness, where stars die, galaxies drift apart, and the universe becomes a frozen void. The Big Rip, a violent tearing apart of everything, as dark energy grows stronger and eventually rips galaxies, stars, planets, and even atoms to shreds. The Big Crunch, a reversal of expansion, where gravity pulls everything back together into a fiery collapse, perhaps giving birth to a new cycle of creation. These are not just science fiction ideas, they are real scientific theories, built on our best understanding of cosmology, dark matter, and dark energy. Each possibility paints a very different picture of how the cosmic journey might conclude. The Big Freeze, the universe of eternal winter among all the theories about the end of the universe. The Big Freeze, also known as heat death, is currently the one most scientists consider most likely. It's not the most explosive or violent ending, but it is perhaps the most haunting, a slow fading into eternal darkness and silence. The science behind the Big Freeze. To understand this scenario, we first look at how the universe is behaving today. Since the Big Bang 13.8 billion years ago, the universe has been expanding. In the late 1990s, astronomers studying distant supernova made a shocking discovery. The expansion is not slowing down, as once thought. It's accelerating. This acceleration is driven by a mysterious force called dark energy, which makes up about 70% of the universe. If this expansion continues forever, galaxies will keep drifting farther apart, and the universe will never collapse back on itself. Instead, it will gradually stretch into a cold, lonely emptiness. The death of stars. The Big Freeze unfolds over trillions of years, timescales almost impossible for us to imagine. In the next few billion years, stars like our sun will eventually exhaust their fuel. The sun itself will become a red giant, and then a white dwarf. Across the cosmos, stars will slowly burn out, one by one, until the night sky loses its brilliance. After about 100 trillion years, star formation will completely stop because the gas and dust needed to create new stars will be used up or scattered too thin. The universe will no longer sparkle with new light. It will be filled with old, dying remnants of stars. The age of black holes. As time stretches on, black holes will dominate. Stellar corpse, neutron stars, and black holes will make up most of the matter left. Galaxies will become dark graveyards of dead stars, orbiting black holes at their centers. But even black holes are not eternal. Through a process called Hawking radiation, they slowly lose energy and evaporate. After an almost unimaginable 10,100 years, that's a 1 followed by 100 zeros. Even the largest black holes will vanish into nothing. The final cold darkness. What comes after black holes are gone? A universe filled with only faint, low-energy particles, electrons, photons, and neutrinos drifting endlessly through space. At this stage, temperatures approach absolute zero -273 graus Celsius. There is no usable energy left for any kind of activity. Time itself still flows, but nothing of significance ever happens again. It is the ultimate stillness. A cosmic graveyard, where the universe continues to expand forever, but with nothing left inside it to create light, warmth, or life. Why it matters. The Big Freeze is the leading prediction because it matches our current observations. The universe is expanding faster and faster. Gravity is too weak to stop it. Dark energy seems stable and unchanging, ensuring expansion will continue indefinitely. Though it sounds bleak, the Big Freeze is also strangely poetic. The cosmos began in a burst of unimaginable heat and energy, and it may end not with a bang, but with a slow, fading whisper into eternal night. The Big Rip, the universe torn apart. If the Big Freeze is a slow fading into silence, the Big Rip is the most violent, dramatic, and catastrophic possible end of the universe. In this scenario, the universe doesn't quietly grow cold, is torn apart, ripped to shreds by the unstoppable force of dark energy. The role of dark energy is the greatest mystery in modern cosmology. It makes up about 70% of the universe, but remains completely invisible. We cannot see, touch, or measure it directly. What we do know is that it drives the accelerated expansion of space. Now here's the key. If dark energy remains constant, we get the Big Freeze. But if dark energy grows stronger with time, then expansion will accelerate faster and faster, eventually tearing the universe apart. This runaway expansion is what scientists call the Big Rip, a timeline of cosmic destruction. The Big Rip is our universe's destiny. The end will follow a horrifying countdown. Billions of years before the end, galaxies begin to drift apart faster than gravity can hold them together. The cosmic web that binds the universe starts to unravel. Millions of years before the end, individual galaxies break apart. Stars no longer orbit their centers. They are flung into the dark void as galactic structures collapse. Thousands of years before the end, solar systems, including ours, are pulled apart. Planets can no longer remain in orbit around their stars. Earth, if it still exists, drifts into the cold dark. Minutes before the end, stars and planets themselves are shredded. The force of expansion overcomes nuclear and electromagnetic forces holding matter together. Fractions of a second before the end, even atoms cannot withstand the force. Protons, neutrons, and electrons are ripped apart. The fabric of matter itself disintegrates in the final instant. Even space-time is torn apart in absolute and total destruction of everything. When could it happen? Some models suggest that if dark energy grows stronger, the Big Rip could occur in about 22 billion years. That's unimaginably far in the future. But unlike the Big Freeze, which takes place over near infinite times, the Big Rip ends everything abruptly. The closer the moment comes, the faster and more violently events unfold, until the universe ends in one final instant. Why it matters. The Big Rip represents the most extreme possible influence of dark energy. It shows us that the fate of the universe depends on the true nature of dark energy, something we still don't understand. Even the strongest forces we know in gravity, electromagnetism, nuclear force might be powerless if dark energy continues to grow. The Big Rip is terrifying because it leaves no survivors, no remnants, no afterglow. It is an absolute end. If the Big Freeze is like a candle slowly burning out, the Big Rip is like the candle being violently smashed into pieces. The Big Crunch, the Great Collapse. If the Big Freeze is a quiet fading and the Big Rip is a violent tearing apart, the Big Crunch offers a very different, almost cyclical ending. In this scenario, the universe doesn't expand forever, reverses course and collapses back in on itself, ending in a fiery, dense, and dramatic finale. The idea behind the Big Crunch: the universe is constantly expanding, but what if expansion slows down and eventually stops? Gravity, the force that pulls matter together, might one day overcome expansion. If that happens, galaxies will stop receding from each other and begin to move closer. Over time, all matter, light, and energy will collapse back into a single, infinitely dense point. This would be the mirror image of the Big Bang. Just as the universe began in a burst of expansion, it would end in a catastrophic contraction, a timeline of cosmic collapse. Billions of years before the end, the universe's expansion halts. Galaxies, instead of drifting apart, begin slowly moving toward one another. Hundreds of millions of years before the end, galaxies collide and merge on massive scales. The night sky grows brighter as countless galaxies crowd together. Millions of years before the end, temperatures across the universe rise. Stars, planets, and even black holes are packed into an increasingly smaller space. Seconds before the end, matter is compressed into unimaginable heat and density. The laws of physics, as we know them, break down. The final moment, everything, galaxies, stars, planets, atoms, and even space-time itself, collapses into a singularity, a single point of infinite density. Rebirth, the possibility of cycles. Some theories suggest that the Big Crunch might not be the end at all. Instead, it could trigger another Big Bang. The collapse of the universe might bounce into a new expansion. This would mean the universe goes through cycles of birth, growth, collapse, and rebirth, an eternal cosmic heartbeat. In such a universe, there may have been many Big Bangs before ours, and many more to come. This idea is sometimes called the oscillating universe theory. Why it matters. The Big Crunch is less likely, according to today's observations, because dark energy seems to be driving expansion faster and faster. However, it remains a profound and fascinating possibility because it ties the end of the universe back to its beginning. It forces us to wonder, is the universe a one-time event, or is it part of an infinite cycle where death always gives way to rebirth? The emotional power of the Big Crunch, and like the cold. What observations tell us? The expanding universe confirmed in 1929. Edwin Hubble first discovered that galaxies are moving away from us, proving the universe is expanding. For decades, scientists assumed gravity would eventually slow this expansion, leading to a Big Crunch. But everything changed in the late 1990s. Two independent teams of astronomers studying distant supernova made a shocking discovery. Instead of slowing down, the expansion of the universe is actually accelerating. Something unknown is pushing galaxies apart faster and faster. This mysterious something was named dark energy. What we know about dark energy makes up about 70% of the universe's total energy. It acts as a repulsive force, stretching space itself. Unlike matter or radiation, dark energy doesn't thin out as the universe expands. It stays constant, or maybe even grows stronger. Dark energy is the main reason why most scientists believe the Big Freeze is the most likely outcome. Evidence for the Big Freeze. Current data shows expansion is accelerating. The amount of matter in the universe, stars, galaxies, dark matter, isn't enough to stop it. Dark energy looks stable, not weakening. This means galaxies will continue drifting apart, stars will eventually die, and the universe will cool toward a frozen, empty state. Could the Big Rip still happen? Yes, if dark energy isn't constant, but instead increases with time. If that's the case, expansion would grow so fast that it eventually tears galaxies, stars, and atoms apart. Some cosmologists suggest this could happen in tens of billions of years. However, current observations don't show dark energy growing stronger, only steady. So the Big Rip, while possible, is less supported by present data. What about the Big Crunch? The Big Crunch would require the expansion to slow down and reverse. For that, the universe would need far more matter and gravity than we observe today. Measurements show there simply isn't enough to pull everything back together. This makes the Big Crunch the least likely scenario based on current evidence. But there's still mystery. The truth is, our understanding of dark energy is extremely limited. We don't know what it actually is. We don't know if it's truly constant, or if it could change in the far future. A sudden shift in dark energy's behavior could dramatically alter the universe's destiny. In other words, science today points to a big freeze, but the universe may still surprise us. So, based on what we see today, the big freeze seems to be the leading candidate for the universe's fate. But because dark energy is such a mystery, the doors remain open for other possibilities, perfs, even ones we haven't imagined yet. The human perspective talking about the end of the universe can feel overwhelming. These theories, the big freeze, the big rip, and the big crunch, deal with timescales of billions or even trillions of years, far beyond the lifespan of Earth, the Sun, or even humanity itself. So, what does it all mean for us here and now? Perspective on time, think about it. The universe is 13.8 billion years old. Our planet, Earth, is about 4.5 billion years old. Human civilization has existed for only a few thousand years, barely a blink compared to cosmic time. This means that whatever fate awaits the universe, it lies so far in the future that it doesn't pose any direct threat to us. Long before stars burn out or galaxies tear apart, the sun itself will have already expanded into a red giant and ended life on Earth. So when we discuss these grand scenarios, it's not about fear, it's about wonder. Why these theories matter to us even if the universe's end is unimaginably distant. Studying it changes how we see ourselves. A sense of scale, we realize how small we are in the vastness of space and time. This can feel humbling, but also deeply inspiring. The power of human curiosity. The fact that creatures on a small blue planet can even ask how the universe will end is astonishing. Our curiosity stretches across billions of years and light years. The value of the present, knowing that everything has an end, even the universe itself can, remind us to treasure the time we have now, with our planet, our people, and our moment in cosmic history. A poetic reflection, each ending paints a different emotional picture. The big freeze reminds us of silence, emptiness, and the passage of time urging us to create meaning while the universe is still vibrant. The big rip warns of chaos and fragility, a reminder that even the strongest forces can give way. The big crunch offers a kind of cosmic rebirth, suggesting that endings may also be beginnings. In all these scenarios, there's one common thread. Nothing lasts forever. Not stars, not galaxies, not even the universe itself. But that impermanence is what gives life, knowledge, and love their extraordinary value. The human story in a cosmic context. When we gaze at the night sky, we aren't just looking at distant stars, we are looking at our future, our past, and our place in a vast cosmic cycle. Perhaps the ultimate fate of the universe isn't something to fear, but something to marvel at, because no matter how it ends, the universe has given rise to us beings capable of wondering about it, exploring it, and telling its story. The final chapter of the universe. So, how will the universe end? Will it freeze into eternal silence, be ripped apart in a violent tearing, or collapse back into a fiery rebirth? Right now, the big freeze seems most likely. The evidence from telescopes and satellites suggests that dark energy is driving expansion faster and faster, and that galaxies will drift apart forever until only cold emptiness remains. But the big rip and the big crunch remind us of something equally important. Science is not finished. The universe still holds mysteries, and dark energy, the key to it all, is one of the greatest puzzles we have yet to solve. In the end, all three scenarios, freeze, rip, and crunch, are not just scientific models. They are windows into the destiny of everything that exists. They remind us that the universe is not permanent. It has a beginning, a middle, and an end. But here's the wonder. Even if the cosmos fades away in trillions of years, our brief moment of existence still matters. Because in this vast universe, on a small blue planet, life arose, and with it, minds capable of asking these questions. The fate of the universe is written in physics. but the meaning of the universe is written in us. And as long as we keep exploring, wondering, and reaching for the stars, the story of the cosmos will never truly end.